All right, now we come to a point where we're going to look at this vocabulary term called extrema. Now, extrema are simply maximums and minimums. Oh my goodness, sorry, I can't spell. Maximums and minimums. All right, now, so on this graph, you would see that there are two maximums. On the graph, there's one, what's called an absolute. Now, that is an absolute max because it's the highest point on the entire graph. But this is still a relative max, and you'll see the word here, relative. This is still a max, but not a absolute max. So you could say this is a relative, or you could call it a local max as well. This would have one minimum. It's here. Even though it's not the lowest point in the graph, it is a relative minimum. All right, but here's a picture showing minimums. This one would be an absolute. This one would be a relative. So I'll just do relative here and absolute. All right, so that's what extrema are. So here it says, estimate and classify the extrema to the nearest 0.5 unit for the graph of x. Support the answers numerically. So there's a picture, and we're going to look for just where the graph either makes a valley or a hump. So this one has two. Has one here and has one here. Both these points are relative, not absolute, because the graph goes higher and it goes lower than those 2 points. So these are both relative. So this is a relative max here. This is a relative min. And we could say that's this is occurring when x is, it looks like these are counting by 2s, relative max when x equals 2. And you could also list it as a coordinate point. It would be at 2. These are counting by 4s, 12. That would be 12 there, so this would be 14. So it occurs at 12, 14. And also, this one over here occurs when x is at -1, it appears. And you could put that point as -1, -8. Like that. All right. Usually they ask for what x equals when you do extrema. So here's one for you to try.